produce the sample space and see how big that sample space is. This is going to be a game that involves two spinners. The first spinner has four possible colors that it can land on, either yellow, red, blue, or green. You spin it away, and we see where it lands. And then once we do that, then I'm going to spin another spinner way down here, and it's going to land on one of four possible numbers, 1, 2, 3, or 4. And now what I'd like to do is I'd like to make a list of the sample space, but I'm going to do this using what's called a tree diagram. A tree diagram is one where I look at all the possible outcomes for the first event and then move down from there and see what would happen for the second part. So here's how we're going to draw this tree diagram. First, I'm going to spin the four-color spinner. And I see four possibilities, and so I'm going to list that with the four colors. And so I'm going to have a red possibility, a blue possibility, a green possibility, and a yellow possibility. Now, for each one of these, I spin the second spinner, and so I see four possibilities for that. And so off of each one of these, I'm going to have four possibilities. I could have a 1, 2, 3, or 4 spin. Here I have four possibilities. I could have a 1, 2, 3, or 4 spin. With green, I could have four possibilities for the second spinner. 1, 2, 3, or 4. And finally, for the yellow, there are four possibilities for that second spinner. 1, 2, 3, 4. And so now I can actually list them all. I can list the entire sample space by noticing that I could have red followed by 1. What does that mean exactly? It means that the first spinner lands on red and the second spinner independently lands on 1. Or I could have had red on the first spinner, 2 on the second, red on the first, 3 on the second, red on the first, 4 on the second. But then there's a whole other set of possibilities if I had blue first. If I landed blue first, then I could have 1 for the second, blue first, 2 for the second, blue first, 3 for the second, and so on. And so if I listed them all, I would see the following. Here's my sample space. I'd have R, comma 1, R, comma 2, R, comma 3, R, comma 4. Those are all the four possibilities I could have if I start with an R. But I could have actually had a blue first. So then I have to list more possibilities. I could have blue and a 1, blue and a 2, blue and a 3. And you can see me going. In fact, how many am I going to have? Blue and 4, that takes care of the blue. Now I've got the greens. So I've got green 1, green 2, green 3, green 4. And there's one more. Do you see it? It's the yellows. I could have yellow 1, yellow 2, yellow 3, yellow 4. Oops, 2, 3, 4. Now, let's take a look. This entire collection represents the sample space, where each one of these is a possible outcome. Let's just make sure we understand, for example, what this outcome right here means. That means that the first spinner lands pointing on green, and the second spinner lands pointing on 3. And now what's the size of this space? Well, we just have to count all the possible outcomes. And if we count all the possible outcomes, we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the total size of the sample space is actually 16, and we could actually have seen that. Because notice that all I did was I took one of each of the first four possibilities, and I multiplied, I put an extra 4 on each of those. So there was 4 times 4. And you can see that here. 4, 1, 2, 3, 4 colors, and 4 numbers 1, 2, 3, 4. It's a 4 by 4 grid, and so you can actually see that if we multiply 4 by 4, we get the sample size. This is actually an example of what's called the fundamental principle of counting. We can use that to actually find the size of sample spaces.